Hey Pre-Calc, let's take a look at a lesson on inverse trig functions. Okay, inverse trig. Inverse means to go backwards. To go backwards. It's the inverse, or to undo. Backwards or undo. Okay, so what happens is we're going to state the angle as the answer, and we're doing trig functions. Okay, so normally we would say the sine of pi over 2, the sine of pi over 2 is 1. Okay, but what if I went backwards and said sine inverse? That's how you say inverse. It looks like a little -1 power. And what if I tell you the sine is 1? Okay, you have to tell me what angle do I go to on the unit circle that gives me a sine of 1. Okay, and the answer is pi over 2. All right. In order to do this, there's a couple things I need to mention. Okay, sine inverse looks like this. Sine with a little -1 power. Okay, it also can be written as arc sine. Arc sine means the same thing as sine inverse. You see some of the problems down here are arc, and some of them have a little -1 power. Cosine inverse can look like that, or it can look like arc cosine. Okay, tangent inverse can also be known as arctan. It's the same thing. Okay, if I see arctan, sometimes I'll even just write it as tan inverse, just so it looks, usual. I have to tell you where you're allowed to look. Okay, so there are some domain restrictions. Okay, inverse domains. So if you're going backwards, okay, I have to tell you exactly where you're allowed to look. And so for sine inverse, we're allowed to look in quadrant 1 and in quadrant 4. Okay, and for cosine inverse, you're only allowed to look in quadrant 1 and in quadrant 2. So the cosines are positive here and they're negative here. We don't need more places to look. We only need one quadrant of positives and one quadrant of negatives. Okay, where are we going to look for tangent? I need one quadrant where the tangents are positive. Okay, so they all use quadrant 1 for sure. Tangent being negative, we're going to look down here in quadrant 4. Okay, now how you say the answers also matters. Okay, so let's just maybe get out a red pen for this. For arc sine, you're allowed to start at 0, and you're allowed to go all the way up to here, okay, which is pi over 2. Pi over 2. Then, okay, you're not allowed to go past all these other places, because that's not where we're allowed to look. Okay, you can't go past blank. You can go down. We can go down to negative pi over 2. So if I needed to say this angle right here, I would not say 7 pi over 4. I would say negative pi over 4. That's how you have to say the answers, okay? Oh yeah, did I tell you the rule? All angles must be stated in radians. Okay, in radians, of course. That's the rule. Cosine is a little easier. Cosine inverse, you start at 0, okay, and you're allowed to look all the way here, quadrant 1, all the way up to pi. So he's never going to have any negative angles. You just go from 0 to pi, okay, and all those angles will give you the variety of cosine answers, the positives and the negatives. Tangent works just like our friend sine. Okay, they're kind of buddies in the alphabet. You can start at 0. You could go up to pi over 2 and say all of these answers. Or you're allowed to swing negatively, negative pi over 2, to say those answers. Okay, once again, if you needed to say 5 pi out of 3, you would not be allowed to say that. You can't swing past this way. You'd have to say negative pi over 3. Which actually isn't so bad, okay? This is where positive pi over 3 is. This would be negative pi over 3. You just say negative answers of those same angles from quadrant 1. Okay? All right, let's do a couple of examples together, okay? These are inverses. Okay, remember, that's the sine, and I'm trying to figure out the angle. All right, so the first thing I'm going to do is consider where am I allowed to look for sine. I'm allowed to look in quadrant 1 and quadrant 4, okay? But this is a positive. I definitely want to go up, okay? So I know when I go up, the sine, the y value is 1. Can anybody tell me what angle has the sine, the y value, be a 1? The answer is pi over 2. Okay, you're trying to visualize where are we on the unit circle. Okay, if you don't like arc sine, you could very easily write this problem as sine inverse of 1/2. Okay, first of all, where am I allowed to look for sine? Quadrant 1 and 4. But this is a positive. Okay, that narrows it down to quadrant 1. Okay, so I'm in quadrant 1. The sine value is the second number. What angle am I at that has something comma 1/2? It's probably radical 3 over 2 comma 1/2, right? Oh, I know that angle. It's pi over 6. If you know your unit circle, you're going to be great at this lesson. Okay, cosine. Cosine, you're allowed to look in quadrant 1 and 2. Okay, 1 and 2. And the cosine is 0. That's the first number, 0 comma something. There's really only one place that has the 0, right? It's right here, 0 comma 1. What angle are we at? We're at pi over 2. Let's keep going, okay? Remember, the answers are going to be angles in radians. Okay, where are we supposed to look for cosine? We're allowed to look in quadrants 1 and 2. Sometimes I write this across the top of the test just to have a reference, but it's a negative value. It's a negative value. So is it in 1 or is it in 2? Yeah, okay, so we're thinking in quadrant 2. Put your brain in quadrant 2. The cosine is the first fraction, okay? So there's the fraction. What angle are we at? It's the pi over 4 family, right? We're at 3 pi over 4. You have to know where you're allowed to look, okay? I know he's also negative down here, okay, but that's not allowed. We're restricted to these certain domains, to these quadrants, okay? All right, let's take a look at letter E, okay? Sine. Where are we allowed to look for sine? Quadrant 1 and 4, but this is a positive, okay? Remember, I'm doing positive, positive. I'm doing positive. I'm thinking about algebra 1. Where is the sine positive? Quadrant 1. The sine is the second value. Okay, what angle am I thinking of? Pi over 3 is the correct answer. This would have a value 1/2 comma radical 3 over 2. Okay, arc cosine. Well, that just means cosine inverse. Okay, but I have to think about the domain restrictions. Cosine lets us look in quadrants 1 and 2. Where do we look for a negative cosine? 1 or 2? That's right. We're going to think about quadrant 2. Put your brain in quadrant 2. The cosine is the first value. Okay. What angle am I thinking of? You got to get all the way over there. It's the ugly one, right? It's the pi over 6 family. But to get way over here would be 5 pi over 6. Okay. Ooh, we have a fun tangent problem. A tangent problem. Tangent, we're allowed to look. We're restricted to quadrants 1 and 4. Okay, 1 and 4 for tangent. Okay. Tangent, where are tangents positive? Quadrant 1 or quadrant 4? Definitely quadrant 1. Okay, so we're thinking in quadrant 1. And remember, tangent is sine over cosine. Sine over cosine. How does it make a 1? Oh, I know. It must be same over same, right? What family has tangent that equals a 1? It's the pi over 4. All right, let's slow down just a little bit because H is going to get a lot more fun. Okay, a lot more fun. Where are we allowed to look for tan inverse? You're allowed to look in quadrants 1 and 4, okay, but he's negative. So we're going to look in quadrant 4. Okay, so I'm going to draw a little doodle here. I'm in quadrant 4. This is sine over cosine. Okay, sine over cosine. So I'm thinking of where is it sine, comma, cosine. You know, I don't really remember seeing a point like that at all. That looks really weird. Where's the rest of it? Oh, I know what happened. I think it got canceled out. Wasn't there some sort of trick where there was something in the denominator and something in the bottom? It was the same thing? Okay, wasn't this the over 2 trick? Yes, yes. Okay, this looks like a point I recognize. Okay, sometimes I like tangent because he actually gives us the sine and the cosine. Okay, so what family are we thinking of here? This is the pi over 3 family. All right, but remember, you're not allowed to swing all the way around. You have to either stay in quadrant 1 or quadrant 4. So I can't swing this way. I'm going to have to swing down. Okay, so the correct answer would be negative pi over 3. All right, we had the over 2 trick, and we had the swing down because you can't go all the way around. All right, this tangent problem looks a little different. That looks a little different, okay? I'm going to try that over 2 trick again. I'm going to try that. If I have radical 3 over 2 and then 3 over 2, I don't remember seeing a point like that at all. 3 over 2. No, hang on. What happened here? What happened here? How did they get a radical 3 over 3? Oh, you know what they did? They must have rationalized their answer. I'm going to unrationalize it just so I can think a little better. So this problem is really tan inverse. Okay, and what is this fraction unrationalized? Well, if you don't know, you could always re-rationalize it. You can rationalize again to unrationalize. If I multiply top and bottom by radical 3, that's going to be 3 divided by 3 radical 3. Then the 3's cancel. Oh, that's right. This is probably 1 divided by radical 3. All right, so I'm trying to think, where on the unit circle does he have sine over cosine? Wait a minute, I don't remember seeing points like that, but I do remember seeing points that had over 2 over 2, over 2 over 2. So there's the cosine, there's the sine. They're both positive. What angle am I thinking of? Pi over 6. Wow, that one should get like a smiley face. Okay, guys, couple more. Okay, sine inverse. Where on the unit circle do we have a sine that is 0? Now remember, for sine, you're only allowed to look in quadrants 1 and 4. So somewhere we have something comma 0. We're not allowed to go negative. We must go positive. So it must be the point 1 comma 0. I'm not allowed to swing around. I can't say 2 pi. I'm going to have to say 0 radians. Okay, we're right here. Okay, cosine. You're allowed to look in quadrants 1 and 2. I'm trying to think of where we have a negative cosine. Negative 1. Negative 1 comma something. I must be way over here. Okay, that angle is pi. Okay, and finally, where do we have a tangent that's 0? Okay, tangent is sine over cosine. Okay, what number are you allowed to put here? You're allowed to put a 1, right? I'm trying to think where we have a point that's 1, 0. That's the sine, that's the cosine. You're allowed to think in quadrant 1 and 4. I think it's right here, due east. Okay? We're not allowed to swing around. You can't say 2 pi. No, no, no. I'm going to say 0 radians. Okay? I can state the domains for the 3 basic trig inverses. Okay? Can you state the domain restrictions? Okay, that's kind of what we started at the top, yes. I can determine the value of a trig inverse. Okay, using the proper domain, can you find the angle? What angle am I thinking of? Good job, Pretel.